All right. Depending on whose clock you're going by, I got 7 o'clock. So welcome. My name is Mike. We're going to be going over some gas furnace schematics today. Just basic understanding. This is a very basics class. So if you are an advanced learner, you already know a lot about the stuff. You might find it boring, but you also might learn something. And those of you who haven't gone over schematics much are going to find this hopefully very helpful. All right. Ah, Today, first thing we're going to talk about is what we're going to go over. We're going to go over wiring diagram types. There's more than one type of schematic you can see. There's a key to all the schematics you're going to be looking at and how to understand those symbols that we're seeing on the page. Important thing here is just knowing what you're looking at and where to get the information that you need. Okay. So the first type of schematic you can see out there is pictorial. Pictorials are like that. It's like someone took a picture of your inside of your furnace and put it on a piece of paper, put on a sticker. So all the parts, all the relative are in the relative position of where they should be in the furnace. So if you have two limits that are right next to each other or something like that, they're probably going to be right next to each other in the pictorial schematic. Blower motors and fans and draft motors are all kind of in their relative position. Is it exactly where they are? No, because sometimes they have things stacked, so they got to put things side by side or kind of out of the way a little bit. But you can see where they come into and out of the circuit board in the relative position where they are on the board, as well as relative position in the furnace. So that's a pictorial. Picture, that's how I like to look at it. It's like someone took a picture of the furnace inside and put it on a sticker for you. Those are really helpful for just knowing when you look at it apart, look on the pictorial schematic and you can kind of see relative to where you're looking in the furnace, where you're going to find that on the schematic. Now the next type is a ladder schematic. Now ladders have nothing to do with where they are in the furnace. Everything on the ladder schematic is going to be how it's easiest to trace out the wires and where they go. So components are not where they look in the furnace, but are laid out so that so the wiring is really easy to follow. So pictorials are like a picture. A ladder is more like say like an engineer would like to see it, right? If everything was just laid out perfectly straight lines for you, really easy to follow. All the connections are, all the parts that connect to each other are right next to each other in a ladder schematic. And so it's easy to follow the electrical voltage, but just because they're right next to each other on a ladder schematic doesn't mean they're next to each other in the furnace. And so you might have parts that are in different compartments side by side in a ladder schematic, but in an actual furnace, they might be one's in the blower compartment, one's in the burner compartment, completely different sides of the furnace. So ladder schematics are great for tracing wires, but not for finding the parts in your furnace. And so if you see it looking like this, where it's all the wires coming off one side of the board, and if I'm going to put a laser pointer up here for you so I can point that out. So here you have your IFC or circuit board, and you'll notice all the wires are coming off one side of the board. Well, we all know that's not realistic. That doesn't really happen. And so ladder schematics, if you see everything on one side of the board like that, you're looking at a ladder schematic, and everything's going to be just all very simple, easy to follow wires. If you notice, the wires are all straight out, straight out, straight out. Everything's all to one side. It makes it really easy to see where things are or how they connect. But when you're trying to find a part in a furnace, it does not always help. But it's great for knowing where to go next. Okay, so that's a ladder schematic. Sometimes you're going to see it like this. You're going to see the ladder schematic and the pictorial schematic side by side. And this is really helpful. I think this is the best. This is ideal when we see them side by side like this, because you can see where they are laid out in the furnace. Then you can look over without having to change pages or find another schematic, and you can see what they go to next, how they connect. Gives you a really simple kind of a sequence of operations kind of way to follow it when you have both side by side. As you can see here on the pictorial, you have some plugs on the left, some on the top, some on the right, but over here on the ladder, they're all on the right. So you can then find this plug here over here and follow stuff through. Makes it Really helpful when they're side by side. Oh. The next part we're going to look at, we have a key. So every single schematic should have a key. A key is going to tell you all the notes about what's on your schematic and how to interpret it. Because not all schematics are the same. Some are going to use different color wires. Some are going to use different symbols. You can have two different symbols mean the same thing depending on your brand, or even sometimes just the year of manufacture. They might change what the symbols look like. You're also going to have different abbreviations. So sometimes they abbreviate things separately. We're going to go over those kind of sections of the key here. And you see I have them numbered 1, 2, and 3. And we're going to go over them in that order. All right. So the first part here is the wires. So if you're not sure if, let's see, is BL, is that black or is that blue? Well, in this case, you can see that BL is blue, not black, even though they both start with a BL, right? So blue is black is BL, black is BK. Not necessarily BK jumper or BK wire, but black is this term right here. So every color wire that's on this schematic in question here it'll tell you exactly what abbreviation for the wire code. So how I look at it is going to be labeled. Makes it really simple. So if you're not sure what PR is, you look at your key under the wiring section, it's going to tell you PR is purple. Obviously, you're going to have ground wires will be green with a yellow stripe, and they tell you that right here, GR/YL. So it's a green wire with a yellow stripe, not a yellow wire with a green stripe. So make sure sometimes you get lots of wires with stripes on some furnaces, and every single one of those will be listed in the wiring section of the key. You're also going to find this part here, which is going to tell us the solid wires versus dashed wires. So solid wires are all pre-wired, connected from the factory. You don't have to touch them. That's just how they are. Now, if you see wires with a dot and dash, those are ones you have to install. So that's high voltage you have to install. That's low voltage you have to install. And you can see the difference in the wire sizes. It'll be to scale on your key, so you should know exactly which one's which. So pretty simple there. I think that's pretty self-explanatory. Most people realize that, but I do get questions from time to time about people trying to read through it and understand which wires are which. Just know that on every schematic that's intact, you should have this information. The next one is probably our most confusing section here, the question we get people probably have the hardest time with, which is all the symbols. As you can see here, we'll start right up here on the top. We'll start at the top left. You're going to have a ground wire, could look like two different symbols of where it's connected to ground. Okay, it may not be this little like a little pyramid or Devo hat. I'd like to look at it. It might look like this little antenna here, right? So find out what your schematic is using for a ground. These are both out of a trained furnace manuals here. So they use two different symbols for ground depending on the manual you're looking at. So if you're not sure where the ground wires are, look at your key, look what you're looking for a symbol, and then you can find those symbols on your map, your schematic. We're going to go across, go from left to right here. The next one's over, you're going to have your flame rollout switch and your thermal limits. So you'll notice that anything that's a thermal limit, a temperature limit, you're going to have this little, well, that's a very small pointer. Let me get a laser pointer. There we go. You're going to have this little, kind of a little box on the bottom of this, of the switch here. So every time you see that shape, that kind of a open-ended box like that on its side, that's gonna be a temperature limit of some type. So the difference between these two limits is this one's got a little bar on top. This one down here does not. Because in this case, it's a flame rollout switch that has a resettable limit. So it's got a button on it. So not all rollouts are going to have a button on them. Some will reset themselves. Some of them will trip and never reset. But if they have a resettable button on top, you're going to have that little bar on top there. If they don't, so just a self-resetting switch, you're going to see that it looks like this. We're just going to have that dangly little box hanging from there. And that could be a reverse airflow limit, a thermal limit, an inducer limit, any type of a temperature limit. It's going to have that shape. And that's pretty much universal across the board there. They're going to have that shape. So you'll also notice as we start looking at these limits and switches, the switch starts here on the left and it goes to the top on the right, the top of that bar. What that means is it's normally closed, it's touching, and when it gets hot, temperature is going to rise up. It's going to lift that switch off of that connection. So these are both limits that open when they overheat on temperature rise. Okay. So thermal limits have that little box. There's always going to be a thermal limit of some type, and they'll show you if it was on a commercial package unit that had a frost stat that would open on a temperature fall. This line would go to the bottom and it'd be connected there. So if it got cold, it would drop open. So always the way you got to look at those things is where do they touch, on the top or the bottom. Moving across to the right here, we've got our pressure switches. You're going to notice some pressure switches are normally closed. Some of them are normally open. Most of them that you're used to are going to be normally open, and this is where we get some confusion sometimes. So in most cases, what you're going to see here is a switch that looks like this. Got the little half circle moon here, a little bell on the bottom of the switch. That's a pressure switch. So that could be any type of air pressure, okay? Or any type of pressure. We're measuring pressure at that point. You're not going to have like a gas pressure switch usually, I don't see, but you're going to see air pressure switches. So these are your inducer pressure switches. In this case, you'll see that it is open and not touching that bar. And so in this case, this specific switch, it's going to close and drop when we have a negative pressure. And so it's looking for a negative pressure from the draft motor. Some pressure switches are looking for a positive pressure. And so they'll be open below. And when they get a positive pressure, they're going to rise up and close, depending on the model, depending on the style of pressure switch. So you got to pay attention to that, of what you're looking for. If you're looking for a positive pressure or negative pressure. I know some pressure switches will be labeled what they do, negative or positive. That being said, your schematic will tell you right there in the drawing, is this a negative pressure or a positive pressure switch you're looking for. Also, you'll see in some of our 90% furnaces, and actually all of them now, all of our newer ones, all the S models, are going to have a condensate switch. You'll notice this is a pressure switch still, and it is normally closed, but it's actually going to open on a pressure drop. So what we're looking for here is this should stay closed, and then when our pressure switch, when our condensate trap is plugged, it's going to get a pressure difference. It's going to drop open. So that's what we're looking for there. So make sure you're paying attention to, this is a normally closed. So under normal operations, closed, right? So that's a difference there. Some of these are open, some of these are closed, some of them close on a pressure rise, some close on a pressure fall. And what's what we're looking for here, okay? Some other symbols you're going to see on a furnace. Now those are all your safeties and that kind of stuff. Now we're also going to have other symbols, and people constantly ask, well, where is that? Well, some things here you're going to find is like a BK jumper. A BK jumper is just a little jumper. It looks like a piece of wire coming off the board, just like that shape right there. And that's what you're looking for. And this is actually a screenshot off of a schematic. So it literally is labeled on the board, BK jumper. But that's what you're looking for, that little jump, that little wire. Not all furnaces, but some furnaces might have a door switch that when you take the door off, it will kill the power to the furnace. Here's what a door switch can look like. You'll see here that it is with the furnace open and off, it's going to be open. When you close the furnace door, it's going to push this little plunger down, make connection from point A to point B, and that closes your contact there to turn the power onto the furnace. You'll also find some furnaces have capacitors. Capacitors would be on either some of your older models with a blower motor, or some of your current ones with a capacitor on your draft motor. And so if you're wondering where your capacitor is, how that wires in, how that connects to the motor in some way, you can follow your wires back from the capacitor. You can see where they go. But that's what you look for. You got a flat line with a curved line coming together there. Your flame probe, your flame sensor, you might see a symbol like this. You might not, but it will be labeled. It will say flame probe, or FP is the most common labeling inside the furnace on the schematic, is FP usually. And that's what you're going to be looking for. It's going to have some type of a symbol. Each schematic could be a little bit different how it is labeled. So make sure you're paying attention to what that looks like on your schematic if you're trying to find it. Sometimes you're going to see this weird symbol. Looks like a lightning bolt. So what that is reference to is, depending on the model furnace, would be a coil of some type. A coil would be a gas valve coil, a relay coil, anything that's going to be like a contactor coil, right? Technically speaking, it's going to have this little, like a lightning bolt in there, and you're showing that this is a not a motor, but this is something that's doing some work. This is closing a contact usually. It's usually the coil that closes some type of a contact, whether that is closing a gas valve contact, closing a fan coil contact, something like that. So you're looking for that lightning bolt. That is a kind of like almost like a motor, but not a motor, but that is something doing some work right there. Okay, it's got some resistance in it, and it's going to go ahead and do some work there. If you're looking for your fuses in the system, some of them are just a fuse on the board and they're really easy to find. Some of them are inline fuses. And it's good to know what your fuse symbol looks like, because if you have an inline fuse somewhere, the easiest way to find is look at your schematic, find what it connects to, and then follow that wire out to where that inline fuse is. So you look at fuse right there, as you can see. To me, it looks like someone cut a circle in half and then just slid them down. And that's how I look at it. The last couple on here that you're going to find in our furnaces, a lot of people say, hey, I got 2 transformers in here. What's the second transformer do? Well, if they look at the schematic, they'll see it's not a transformer, it's a line choke. So it looks like half of a transformer on the schematic. And it's just there to help clean up the power before it goes to your blower motor. So some of our blowers are going to have a choke on them. And if you look at the schematic, it'll tell you exactly what it is. So just FYI, if you think you have 2 transformers, look at the schematic. One might be the second one's probably not a transformer, it's probably just a choke. But that'll tell you which one is which if you're not sure. And the last thing, some of our furnaces are now in the schematic showing an igniter, and it's showing an old style kind of a igniter in the picture. It's kind of funny looking, but they're going to have a different symbol. They're going to show you what their igniter is. These are the current ones. What we're looking at, a modern furnace, so it's going to have an igniter symbol like that. So just know your symbols. These are literally every symbol that I pulled off a furnace. So there might be some other stuff in the furnace. Check your symbols, see what they are before you start kind of inspecting what's going on in the furnace. The last section is your abbreviations. Now, each model might use different abbreviations on the schematic for describing what everything is. And if you see something on the schematic like, wait, what is this? It says IFC. What is IFC? Well, go back to your key, and it's going to give you the abbreviation IFC. As you can see here, IFC is going to be Integrated Furnace Control. That's your board. Probably the most commonly asked question I get about reading this stuff is, hey, I see it says RAF. What's a RAF? Well, in this case, a RAF is a reverse airflow. It is one of our most overlooked limits in the furnace. Pretty much all of our furnaces have now. Reverse airflow is going to be a limit on the blower section, for in case our blower goes out, it will trip when the heat rises up through the blower in a downflow. So you think, well, I got an upflow, I don't have to worry about it. Our upflows are horizontal left and right, and when they're in a horizontal position, we could get heat coming back to the blower, and we're going to have reverse airflow switches on those as well. So most furnaces now have reverse airflow switches, and these are thermal limits, and they're going to be labeled RAF, and a lot of people do not realize what they are, but as you're going to see in the next couple slides, they are labeled as thermal limits. So if you see RAF, you see it's a thermal limit, you should understand that that is a temperature limit of some type. You're going to see, well, what's TH and TR? Well, these are your hot and common 24 volts. MVC, MVL, MVH, these are your main valve. This is your valve common, your gas valve low, gas valve high. Everything's labeled very clearly for what it is. Your line voltage may be an L. Your line voltage may be an H. Look at what your abbreviations say so you know you're looking at the right thing. Other people ask us a lot of times on the blower motor, well, which one is sending the signal? Which one's receiving the signal? You're going to see that TX is transmit, RX is receive. And so they're labeled very clearly on the board, on the schematic, which one does which. So we get calls where people asking us to walk them through it, and it's right there in front of you. So I want to make sure you see it there. And if you just take a few minutes and read through it, it'll be very self-explanatory as to what everything does. So I didn't want to zoom in here on a set of schematics and show you the difference between what a pictorial versus a ladder can kind of really show you. So in this case, we have power leaving the board. We go on this purple wire, comes all the way up here. All right. Oh, that's actually, never mind. I saw that backwards. Purple right here. Boom, purple. High HLO. All right, so you see HLO. We're going to go back. HLO is right here. High limit output. Okay, high limit output coming off of the board. So we're going to follow that HLI. Where'd it go? HLO, high limit output on this purple wire. And it comes down, and it comes over, and it goes to this condensate switch. Now from here, it does go back through the switch because it's normally closed, through the inducer limit, and it comes back up to the board on this one on ILI. Now ILI, I can go back and forth to tell you, but ILI stands for inducer limit input. So we got an output and an input. But that wire also starts here, the condensate switch, and it jumpers off of there and it goes over to another switch, this RAF, which I just talked about, which is our reverse airflow. And it's a thermal limit, as you can see from the symbol. It's normally closed, so the power should go through that one, over here to this RAF, another one, so you have 1 and 2. And you're going to be also a thermal limit, normally closed. It goes up out of that to a thermal limit, that's your main high limit. Comes back to a rollout 2, also a thermal limit. Comes back down to a rollout 1, a thermal limit. Then it hits this pressure switch. Now the pressure switch, as you can see in this application, is open right now because this is in the off position. And the yellow is going to come back up. So it's going to jump off that because it's open, so it can't go that way. So it's going to go over here, up to pressure switch 2, also open. And because it's open there, it can't go that way. So it then comes back on this brown wire, comes back to HLI. HLI is high limit in. When this furnace turns on, pressure switch number 1 is going to close. You're going to get orange wires going to light up. PS1, or PSI, pressure switch in. And then you have PS2 on the brown wire when you go into high stage, PS2. So really simple. This is a ladder schematic, really easy to follow. Simple, you can see how it goes from switch to switch to switch to switch, and you can follow that power very easily. Problem is, that's not realistic. Here's what it looks like on a pictorial schematic. This is what it looks like in the furnace. Looks a lot different. So I couldn't make this fit on the screen and show the board all at once because everything is so spread out on a pictorial schematic. But if you remember, we came into on a purple wire into our condensate pressure switch first. So this purple wire here, that's our power in. So it hits here, and it goes over through that closed condensate switch, which is a pressure switch, to an inducer thermal limit and back to the furnace on our inducer limit in. But it also splits off, and here's where a pictorial is extremely helpful, because in reality, things aren't all boxed together. Right? We're spread out all over the furnace. Some of these limits are on the burners, some are on the heat exchangers, some are in the blower compartment. And this kind of gives you a better idea of where everything is. So as we leave that condensate switch, you'll see it goes over here to a plug, right? A harness, a wire connector, right? And it goes out of that one to another plug, a big old 12-pin plug here. And then this one goes up to our, this is actually this plug, if you pay attention to where this is where it goes into the blower compartment. Because you can see the blower motors right here. Here's these switches, right? They all go through that plug. And you get into the reverse airflow 2, reverse airflow 1, back out to this plug, out of that plug over to this other plug. And then this goes up to another plug, because this is in the burner box now. We had to get a plug to go into the burner box. So from there, we go to our thermal limit, flame rollout, and then we come back to this plug, which comes back to the pressure switch 1, which is open. Go back, pressure switch 2, which is open. We go back on this brown wire back to the furnace, and that'll be our high limit in. So the great thing about this pictorial versus the ladder is on the ladder, everything looks very simple, just straightforward, easy to follow. And you can check which limit goes to which limit. But on this pictorial, they are all over the place. But I love it because when I look at this pictorial, I can see that if I need to measure these reverse airflow limits, I don't need to get to them. Because if you know anything about our S model furnaces, there's a wall between you and those limits. There's a panel that's held on by like 14 screws, and you got to remove a whole bunch of stuff to get to it. That's not always simple or quick or easy. But if I know by looking at the schematic that these go on a loop, if you look, they come in, go through these two limits, come back out. and they don't touch anything else. So I can just go to this plug, this 12-pin connector here, Molex plug that goes through that wall. I can unplug that plug and ohm through those two pins, those two wires. I don't need to get to the individual switch to measure it. I can measure it from the plug. That's where the pictorial schematic really excels. It gives you a lot, and you can don't even need to go to this plug. If you look right, you can go back to this plug right here. And so you can measure from this plug, these two yellow wires. You can ohm from there. You can check your AC voltage there. You don't need to go into the limit. Now, if you see that that limit is open, you don't know which one of these limits is bad, possibly both, possibly just one. They're the same limit. So, but if they're both bad, you're going to need to get two of them. So you will need to, if you find that that is what's open, you'll need to get to those. Some furnaces only have one reverse airflow. Some have two. So it's important that you look at the schematic and you can see what's going on there. So that, I think, kind of sums it up what we're looking at today. I just wanted to be very basic, very simple. I know you guys are all very busy with this weather where everyone's having, so I don't want to waste a lot of your time. I want to be very straight and to the point. But the big thing that's important for them, this is it, we're down at the end here. The big thing I wanted you guys all to know is that there's a key. There's listing. It's showing you everything that is going on the schematic, and there's that key, and that key is really the most important part. With that key, it tells you what your wires are, what their colors are, what everything, how they're labeled, what's in the system. Some of our older furnaces didn't have the reverse airflow. So if you don't have one of those, it'll tell you down in the key, it'll tell you if you have a reverse airflow limit. It'll tell you on the schematic where that limit is located, what it's connected to. And when you're doing your diagnostics, that's going to be really important, is knowing what's connected to what order the power goes through each of those limits. That's really the most important part there, is knowing the sequence of operation, how the power goes through all your limits. But that's where we're at. Does anyone have any questions? You can type it in the chat. All right. If no one has any, awesome. If no one has questions, then I know you guys are very busy. I want you guys all be safe out there. Everyone have a great day. I appreciate your time. Outdoor units. That's a good question. We are going to be doing another one of these just on refrigeration and outdoor units coming up here in a couple months. So that's going to be, yeah. So as far as those pressure switches on your outdoor units, we are going to have one of these just going over all the different types of switches and controls in outdoor units. As far as that, they should be labeled. You're still going to have a schematic. You're still going to have abbreviations, HPCO, LPCO, high pressure cutout, low pressure cutout. So those still will be labeled on your key and your outdoor units. We're going to go over that in better detail in a couple months. But that is a big thing that people have questions on. They get them mixed up, the high pressure and low pressure. Someone else had a question. Difference between a switch and a load. So a switch, great question. So a switch is just look at like a light switch. A load would be the light. So the difference between a switch and a load is a switch is just letting power travel through it. A load is using the power. That's how I like to see it. One is just like a gate, and the other one is actually doing the work. So that is a very different thing. As far as a switch and a load, usually you're going to see your loads are going to be motors or coils, or like we went over some of that symbol of a coil, that would be a load. Any motor would be a load. All the stuff leading up to the load is going to be switches, whether that's an on-off switch, or that's going to be a safety switch of some type, whether that's a pressure switch or a thermal switch. Those are all things that could cut the power off to your load or turn the power on to your load. But the switches don't have any resistance in them, and they should all be they should all read out, if you're ohming them out, as 0 when you're trying to check for resistance. A load will have resistance through it because it's doing work, so there has to be some resistance to it because no one wants to do work, so there's always resistance. I hope that explains that kind of simply. I'm trying not to get too complicated here. I'm trying to keep it really simple here, but yeah, a load is anything that you want to turn on. anything that you are trying to use. So whether that would be, like I said, a gas valve or a blower motor or a fan motor. There's even a load on like on your circuit board because you're having lights turn on. So that can actually be a load as well. So every time you see a light turn on the board, that's a load, not a switch. So, okay. Any other questions? Awesome. I'll try to keep this down to 30 minutes just because I don't want to keep it simple and not do too much information. So we're at 7:30 now. Um, if you guys have questions, please, you can text things into our tech support line, 253-620-8282, or you can give us a call. I hope this was helpful for some people. If it was too simple and you already knew it all, great. I'm glad you know that stuff. Please share it with your coworkers, make sure everyone's all on the same page. Thank you, everyone. Have a great day.